We have already obtained the output or drain characteristics of junction field effect transistor, and in this lecture we will obtain the transfer characteristics. So what is the transfer characteristics? This is the first question. What is the transfer characteristics? Transfer characteristics of junction field effect transistor is ID versus VGS plot keeping VDS constant. In case of JFET, transfer characteristics is ID versus VGS plot, ID versus VGS plot keeping VDS constant. Very simple. And we already know ID is the output current, VGS is the input voltage, and we are keeping the output voltage constant. So in case of transfer characteristics, we obtain the plot between output and input quantities, and in case of JFET, the transfer characteristics is the plot between current ID, the drain current, and gate to source voltage VGS. Now in case of BJT, in case of bipolar junction transistors, the output current, which is the collector current, is the function of input current IB, and more precisely we can write IC is equal to beta times current IB, where beta is the amplification factor and it is constant, beta is constant, and current IB is the control variable, and we can see there is linear relationship between the current IC and the current IB. This is very important point. There is linear relationship between current IC and current IB because beta is constant. But in case of junction field effect transistors, there is no linear relationship between the output and input quantities. We already know the drain current is the function of voltage VGS, and the relationship between ID and VGS is defined by Shockley's equation. ID is equal to IDSS inside the bracket 1 minus VGS divided by VP and the whole square. This is very important relation. ID is equal to IDSS, the maximum drain current, inside the bracket 1 minus VGS, the gate to source voltage, divided by VP. VP is the pinch off voltage, and the whole square. This relationship is important. You will have direct questions based on this relationship. And in this equation there are two constant quantities. The first one is IDSS, the maximum current through the JFET is constant. VP, the pinch off voltage, is also a constant quantity, and VGS, the gate to source voltage, is the control variable in this case. Now the equation is non-linear because of the square term. You can see square here, and because of this equation is non-linear, and if you decrease VGS, if you reduce VGS, the drain current ID will increase, and that also exponentially. So there is exponential increment in the drain current if you decrease the gate to source voltage VGS. Now we will obtain the transfer characteristics, and there are two ways to obtain the transfer characteristics. There are two ways. The first way is to use this equation, using the equation, and the second one is using the output or the drain characteristics, and we will use the second way. We will use the output or drain characteristics because we already know how to obtain the output or drain characteristics. Now I will quickly draw the output or drain characteristics, and using it we will obtain the transfer characteristics. The x-axis is for voltage VDS in volts, the y-axis is for the drain current ID in milliamps. For this curve, the maximum drain current IDSS is equal to 8 milliamps and the pinch of voltage VP is equal to -4 volts. This is the first curve obtained at VGS equal to 0 volt. The second curve is obtained at VGS equal to -1 volt. In the same way, VGS equal to -2 volt. This curve is for VGS equal to -3 volt, and the last curve in which the drain current is equal to 0 milliamps is obtained when VGS is equal to -4 volts or the pinch of voltage. So this is the output or drain characteristics, and now we will obtain the transfer characteristics, and for that you have to draw the graph like this. The y-axis is again the drain current ID in milliamps, and the x-axis is for the voltage VGS in volts, and we already know the relation between ID and VGS is non-linear. From this equation we know the relation is non-linear, but we are using the output or drain characteristics to obtain the curve. So let's see how we can use it. The first thing we have to do is to mark the x-axis. This is origin 0, -1, -2, -3 and then -4. Now I will draw the vertical line like this. I will do the same thing for all the 4 points, -1, -2, -3 and -4. Now I will extend the horizontal line like this. And for the first curve in the output characteristics, when VGS is equal to 0 volt, is intersecting at this point when VGS is equal to 0 volt. So this is the first point. I will do the same thing for the second curve, and we have the second point. For the third curve we have this point. For the fourth curve we have this point, and for the last curve when ID is equal to 0 milliamps we have VGS equal to -4 and ID equal to 0 milliamps. Now we will join these points. We will join these points like this, and this curve here is the transfer characteristics of junction field effect transistor. So this is how you have to obtain the transfer characteristics. And this current here, this current is the maximum drain current IDSS, and at this point the drain current ID is equal to 0 milliamps and VGS is equal to the pinch of voltage VP. Now why we are having the non-linear curve we will discuss. If you see the output characteristics, then you will find on decreasing VGS, making it more and more negative, the spacing, the vertical spacing is decreasing. This means on decreasing VGS in the equal intervals, current ID is not decreasing with the same ratio. And because of this reason, when you plot the transfer characteristics, you will have the non-linear curve. But in case of BJT, this is not the case. When you decrease the base current IB, the collector current will decrease with the same factor. So this is all for this lecture. See you in the next one.